Currently, I will be speaking about unveiling the power of Google Cloud Object Tracking, enhancing insight and efficiency. So I'm a software engineer at Motional right now, and this is more about me. So currently, I'm working in Motional. It's a driverless vehicle company based in Singapore. And previously, I worked in Spotify and Traveloka. Currently, I'm also a master's student in data science at University of Edinburgh. Aside for Google Cloud related things, I'm also active in the Cloud Native Foundations thingy. For example, like Kubernetes, and I'm also active in the Women Tech Makers and Women in Data Science. Previously, I'm also a mentor for Grasshopper Open Source Day in 2022 and become for track chairs for machine learning and data for KubeCon and Cloud NativeCon EU for 2021 and 2022. So this is the today agenda. We will be having why object tracking matters in data-driven world, and next we will be having Google Cloud Video AI transforming video intelligence, and next we will be talking about object tracking specifically, and next we will be having the case study for MPCT management transformations with Google Cloud. So why object tracking matters in data-driven world? So you can see on the screen that there is a road where there is like a lot of vehicles, and there is like a bounding box for each of the objects that we have. And what is actually object tracking? So object tracking is the process of identifying following objects like people, vehicles, items over time using data captured from various sources such as cameras, sensor, and GPS. So imagine that you have like driverless vehicle or maybe some kind of like police CCTV. You can actually identify what kind of like object that can be seen through the sensor or like cameras that actually available. And what is the functionality for it? So it is actually not being used to identify the object. It also tracks the locations for the objects in the space and also predicting their future movements and behavior based on accumulated data. So this is the graphic on the increasing number for publications in object detections from 1998 to 2018. We can see how much it already increased over the years. And mostly it's actually about the real-time insight, meaning that, for example, like for my case before, there is a real-time object detections, for example, for driverless vehicle, or maybe like inventory related details for retails. And there is actually the emphasis of the value of immediate data processing and analytics for timely decision making. And there is also like predictive analytics, real-time tracking feeds into predictive analytics, allowing business to forecast future trends and behavior with higher accuracy. What is like the correlations between object tracking in business? We want to gain more granular insights. For example, like we have a customer behavior analytics where we are eventually tracking customer movements and interactions, and we will be able to kind of like gain patterns, preferences, thus leading to personalized marketing and improve customer experience. Another example will be like asset management. Imagine that you are in the logistic and manufacturing sectors. You want to kind of like making sure that the streamlining process between providing the insights into the operation workflow, making sure that all is in place. And then this is like real world examples. We want to kind of like enable automated object tracking system to process and analyze data much faster than the humans, which is crucial in environments where real-time tracking and immediate data processing are essentials, such as in logistic, manufacturing, security, surveillance. And we also want to make sure that it can be easily scaled to monitor large number of objects simultaneously, because there is like uh, we understand that human is prone to error when we need kind of like focus on multiple details for surveillance related matters. So yeah. And then how Google Cloud Video AI actually transforming the video intelligence technologies. So this is how video analysis can be used. Video analysis we will have with the Google Cloud Video AI. So we have like precise video analytics. We can recognize over than 20,000 objects, places, and actions in streaming video, and then we can extract the frames and metadata for each of the layers, for example. And we can create our own custom entity labels with AutoML video intelligence. So we can use like the existing models and then playing around with adding more annotations for each of the layers that we have on the video. And then we have simplified media management, meaning that we can search our own video catalog the same way as we actually search documents. And then we will be able to kind of like extract the metadata, and this can be used to index, organize, and search the video content, as well as control and filter content for what's most important. And we can easily create intelligence video apps where we can gain insight from video in near real time using streaming video annotations and trigger events based on object detected. And we can also engage in customer experience with highlight reels, recommendations, and more. So this is the difference between the AutoML video intelligence and video intelligence API. For AutoML, it provides us a graphical interface for easy custom model training. And for the video intelligence API, we will have the pre-trained models for recognizing numerous objects and actions with continual improvements. So if you are still new, probably you can try the AutoML video intelligence and use like the existing graphical interface. But if you want kind of like do some kind of like iterations, then you probably want kind of like use the video intelligence API more. So this is the key use cases for Google Cloud Video AI. This is like content moderations. So we can kind of like instantly moderate content across extensive data. And we can provide content recommendations, build recommendations engines using label and user preferences based on like video layers, for example. And we can also add like a media archive, create indexes archive for easy accessibility. And then we will have like contextual advertisement by identifying optimal and placement based on the video content. Next, we will talking more about object tracking itself. So what's the difference between object tracking and label detections? Because eventually with using label detections, we will be able to kind of like know what kind of like object it is. So the distinct features will be unlike label detections that only provides label without special context. Object tracking offers labels for individual objects with bounding boxes to see the multiple objects that we have on the video, for example, at every time step. So, for example, imagine that we have like multiple cars inside of like roads. Then if we are only using the label detections, we can only identify that all of those are cars. But using object tracking, we will have the locations, for example, the special context, and then we will have like the object ID. And we will also having like the label, for example, like pedestrian or maybe like vehicles or other things. And this will be processed on like time step basis for each of the time frame for the videos. So this is more about like object tracking. We will be having like multiple object tracking. We can detect and track multiple objects in the video and returning the labels or tags associated with each detected entity, including the locations for each entity within the video frames. And the limitations will be very small object within the video might not be detected. And the difference from the label detections, we already talked about this before. And we will be having more detailed labeling and time segment informations because of the object metadata for each of the object track entities. And we will having additional entity informations based on the Google Knowledge Graph Search API. So based on the entity ID and then the locations, we will be having more information regarding that. So understanding object tracking, in the context of Google Cloud Video Intelligence, it involves analyzing video content to identify and track objects throughout the video durations, meaning that it will analyze per frames entities and then will track each of the objects available at a given timestamp. And to initiate object tracking, the annotate method is called by object tracking specified in the features field. And then we have the key features of object tracking, that is the entity and locations annotations. The system annotates video with labels for detected entities and their spatial locations. For instance, a traffic video might generate labels like car, trucks, bike, etc. And we have bounding box and time segment, where each label is actually coming with bounding boxes and each associated with a time segment indicated durations of offset from the video start. So we can trying to kind of search based on the offset and look at the motions of each of the track IDs that we are having on the videos. And then we will having the entity informations. So the annotation itself will include additional entity information such as the entity IDs, and this can be referenced in Google Knowledge Graph Search API for more details. So this is actually one of case studies for a smart city management transformations that actually using Google Cloud. So imagine that we have a cities that contains 63 potholes. There is a lot of holes on it, and we are wondering if there is a way to make the government efficiently repair these potholes. And then this is the fact that approximately 3,200 work hours were dedicated to annually to pothole repairs, which is a lot of manual works, and it might not be as efficient as we want it to be. And then residents used MemPIS 311 and an app to report the issues, meaning that this is basically based on the users contributions to the apps, and then we will try to gather where the issues is mostly located at, and this unfortunately only capture about 20% of the problems, and it's still not that efficient. So what can we do improve these conditions, given that we already tried to outsourcing the information from the users, but it's still not covering that much of our problems. So fortunately, we have the city bus, where the city bus itself having more data, for example video, using a camera, and it actually track down how the road conditions, and then in a sense based on this information, we can actually store this data and then process this data later and evaluate the video with AI and decide which course of actions to take if there is a potholes on the roads. And based on these recommendations, we can dispatch crews only on the necessary place, right? So imagine this is the data that we get from the cameras from the bus. There is utility poles and then wire loop, and everything is actually tracked. And we can see that there's a bounding boxes and then track IDs for each of the objects and its movement. So we can easily identify which utility poles that we want to track, for example, and where's the locations and the timestamp where the events is actually happening. So we can sort out the priority of which one that we want to fix first. Right, so this is like the flow on how it works actually. So imagine that we have like the cameras and sensor data from the city bus, and we want to kind of like ingest that into cloud storage. And we will have like data pipelines using data flow, and we will store it in cloud storage and BigQuery, and doing some kind of like analytics first to understand how the pattern is. And after that, we already kind of like understand what kind of like technologies that we want to go, which is kind of like machine learnings by using like object tracking. And we will be using AI platform, Vision API, and TensorFlow, for example. And the output can be seen by maybe the government or other stuffs, right? And it can be deployed on like App Engine, for example, or BigQuery, which allows like people to kind of like get recommendations on which ones that kind of like being urgent to be fixed first. So this is like an example how like Memphis cities actually shows the recommendations for the government to dispatch the crews. For example, here's like an unreviewed issues, and there's like the detected date based on like the informations on informations from the bus cameras. We understand that object tracking will provide like the timestamp, right? And we know like when this video is actually being taken. And we will have this checkbox of being unreviewed, meaning that this is like a new case that needs like attentions from government, and the government can decide whether we want to like fix these issues first or not. If let's say there's like a lot of data that report there is like same problems for a specific track ID, which is like the track ID for the roads, for example, then it might be like something that kind of like urgent to be fixed. And this in turn is actually saving quite a lot of like costs. It saves around like 10K until 20K in a year in related to claims, and enhance the prioritizations and discovery of issues like incorrectly paved areas, which is like quite nice because we don't need to kind of like do the job manually, but we still be able to kind of like prioritize the like fixing of the issues. And yeah, we will be working more efficiently with dispatching the crew to like the area that we want to fix.